Welcome back to NoSQL series. In this video, we'll be discussing the important topics of fifth module. Fifth module comprises of the graph database. So graph database is a very easy topic and there are nearly 5 topics under graph database which you can cover very easily. If you are new to my channel, do check out the NoSQL playlist where I've tried uploading module wise videos and I've also uploaded the important questions video. Along with that, even the solved model paper is also available in the Gdrive. Go check it out and subscribe to my channel so that you don't miss out any of the updates. So let's get started. Which we'll encounter is what is graph database. So we'll understand what is graph database, what are its components, and we'll also look into a figure to explain the graph database. So all these things combined could be asked for 10 marks. So graph database will make use of a graph structure. So we know graph structure will comprise of edges and there will be nodes. So these edges will contain the relationship, okay, and these nodes will have the entities between the entities. There are multiple entities are present as the nodes here. So nodes will represent what are the objects or entities in that particular domain. So each node can have their separate properties, like it could be the name, age, or type of that node, or any other descriptive information. So we can think of nodes as instances which are created of an object in an application. So speaking about the edges will represent the relationship between two nodes. We can tell that nodes are the building blocks. So because if the nodes are present, then only we can connect those nodes together, right, and thereby form a graph, right. So nodes will have edges will have properties like type, and along with that there will also be additional metadata information is also available. For example, let's take two friends, okay. So A and B are two nodes, and here the relationship which I have specified here is friend. So friend is the property, okay, which I have specified between two nodes. Suppose if I write A, B, friend, since will tell from when the relationship was established. So in edges we have two types of edges, either it could be unidirectional or it could be bidirectional. Unidirectional edges means A, B, A boss B. So A is boss of B, or B works under A, something like that. Whereas if you write A, B, and here if you write friend, so you are seeing arrow on both the directions, right? So this is bidirectional. Bidirectional, it will say that there is mutual relationship established between A and B. A and B. So that way we can tell A and B both are friends with each other. So by edges will have properties. Along with that, even this all such metadata, no, which I explained, will further help us to enhance the relationship or explain it in a better format. Okay. Speaking about the organizational advantages, so graph database will allow for flexible organization of data. So the relationship between these nodes are explicitly stored and enabling them to discover the complex patterns. So by explicitly storing this, it will help us for efficient queries without the need of computation. Heavy computation is not necessary here, or any schema changes are not necessary. You can easily get the data here. So here nodes and edges are stored only once, but they can be interpreted and queried in different formats. Okay. Then this flexibility allows evolving data models, unlike the rigid models which are present in the relational databases. Next, if we speak about querying and the traversal aspect, so querying involves traversing the relationships to explore connection between two different nodes. So when we query, when we write a particular code, we'll understand what is the relationship between these nodes, right? And that's when we can get our whatever answer I want, I'll get the answer. So traversals are fast here because relationships are persisted in database and they don't need to be computed at every query time. So the relationships are established here, and even if the power goes off, yet this relationship would be there. It won't go off, right? So thereby persisted relationships are established. That way, if I have to find the relation between A and B, it is not, I need not look into in detail, okay, I did not compute them from scratch because relationships are already established, so I can easily query them. So thereby traversals are very fast here. So these are well suited for intricate interconnected data applications like social network, fraud detection, and many other applications. So graph traversal is very easier here. That's why when you're dealing with social networks or any complex interconnected relationships of the data, then you can go up with the graph databases. Speaking about the advantages, first one is flexible schema. That is, new relationships or new queries do not require a schema or data migrations here. Next, we have faster queries. That is, traversing is very fast compared to the traditional method. In traditional method, we made use of joins, but then here you can easily traverse through the relationships and get your data. Next, we have join operations. That is, relational databases will make use of join to connect the tables, but then here it is very easy because the relationships are explicitly stored here. You can traverse very quickly and efficiently, you can get the data. Next we have is model flexibility. Model flexibility means graph databases are not just limited to a single type of relationship, but then nodes can have diverse or numerous connections. Right, so one node can have multiple connections and we can easily get the data from all these multiple connections. So there is richer representation of all the complex domains which are present here. So if you look at this figure, it explains about the graph structure. Okay, in this figure, the ones which are represented in box are the name properties. Okay, for example, Bigco, Anna, refactoring, Martin, all these are properties. Okay, so then we have likes, employee, author, friend, author, all these are the edges or the relationships which are established. So if you see likes here, it is unidirectional, right? That is, Anna likes refactoring. Okay, but if you see bidirectional, let's say, where's bidirectional example, let's say these two. So NoSQL distilled Elizabeth. So suppose let's say friend is a relationship which is bidirectional, meaning both Martin and Pramod are mutual friends. Next, we can easily query the data from these structures. For example, get all nodes employed by big co that like NoSQL distilled. So in this, I can start traversing relationships like employee and likes, and then I can get the data. So by making use of this, it becomes very easy to get the data, and unidirectional, bidirectional, edges, nodes, all these have been explained. I explained all these, right? So yeah, this was about the basic introduction about the graph database. We'll look into the graph database solutions. Okay, so we have Orient database, Neo4j, then we have Infinite Graph and Folk database. So Neo4j is highly popular graph database, which makes use of the property graph model and Cypher query language. And by making use of this language, it will store the data and it will fetch the data easily. Okay. Then we have Orient database. Orient database is a multi-model database that will support graph, document, object, key value, everything. Okay. Next we have is Folk database. Folk database is a distributed graph database which is optimized for handling large scale straightforward graph traversals. In infinite graph is a concept which comes under the Java topic, right? Which comes under Java programming. Yeah, again it also supports the graph database execution. We have is features of graph database. Either all the features could be written here and they could be explained for 10 marks, or they can ask just two features like consistency and transactions could be asked, and together it would be for 10 marks. Or in some cases even the query features could be asked for 10 marks. In model question paper, query features have been asked for 10 marks, so don't miss this out, it is very important. And scaling is also asked for 10 marks. Just scaling of graph database, explain it properly with a diagram, for 10 marks it was asked. Okay, so let's look into the features. So graph database are uniquely suited for relationship oriented data, because in our data each and every node is being connected with one or the other relationship, right? And that's how the actual data is being stored or the database is being retrieved. So these are useful in situations where the focus is on relationships and connections between the entities. So when connection is given priority between the entities, how they are connected, what is the relation, at such situations we can make use of graph databases. So here it offers many powerful features. Let's look into those features one by one. First feature which we come across is consistency. So consistency is very important because it is very critical due to their reliance on tightly intercoupled nodes and their relationships. So we can say that A and B are tightly coupled with each other. A is a friend of B, so this is tightly coupled, it cannot be changed further. Okay, so that way they are tightly coupled, and consistency is very important. So if this relationship get altered, or if this connection gets altered, it becomes inconsistent, right? So we may not be able to get the data or understand what are the insights from this data. So that's why consistency is very important. One is the single server consistency and another one is cluster consistency. We'll look into single server consistency. Graph databases like Neo4j are fully ACID compliant within a single server. Fully ACID compliant means it will follow all the operations of ACID properties like atomicity, consistency, isolation, durability for all the operations which are performed in the graph databases. So nodes and their relationships are tightly coupled here. Okay, tightly coupled means every relationship must have valid start node and there has to be a valid end node. So relationships are never allowed to be in the dangling state. Okay, dangling state means suppose the start is there but then end is not there. In such conditions it is not allowed here, it is not entertained here. So we are strictly telling that there has to be a start node, there has to be an end node, there is no chance for dangling nodes to appear. So nodes can be deleted only when they are free of all the relationships in order to maintain the data integrity. So suppose let's say A and B, I want to delete A, but then A has a relationship with B. In such conditions, I cannot delete A. Only after removing this relation, I can then delete A in order to maintain the data integrity. Next, speaking about the cluster consistency. In cluster consistency, example is the data infinite graph. Infinite graph will support node distribution across a server cluster. So in case of Neo4j, it is supported with a specific behaviors. Looking at the specific behaviors, consistency is managed through master slave architecture. So here write happens on the master node. Write operation is performed on the master node and the changes are made and these changes are propagated to the slave nodes over time. That is, eventual consistency for the slaves are happening here. So slaves can handle only the read operation, thereby improving the availability and distribution. So here we are also ensuring that eventual consistency in the cluster is maintained while maintaining the ACID compliance for a single server operation. So we can say that even the ACID properties are being followed here, and along with that even the consistency is eventual consistency is maintained for the operation, for the single server operations. So this was about consistency, very tiny topic. Next we have transactions. So under transactions, the graph databases like Neo4j provides ACID compliance transaction. That is, these transactions are very important for making any changes in the graph, right? So a transaction or a Neo4j design must prioritize availability and scalability and query efficiency. So we are telling that the availability and scalability and the query efficiency are to be given the highest priority. Okay, so let's look into the key features now. First one is mandatory for modification. So it tells that the right operation like adding nodes will require the transactions, will require transactions to happen. But then if you are speaking about the read operations, they can be performed without any transaction. So without transaction, Neo4j throws not in transaction exception. So transactions are very important when you are performing the write operation. They are not important when you are performing the read operation. And without transactions, it will throw this exception. Next we have transaction workflow. So transaction workflow, it will tell us that a transaction has been initiated using the begin tx. Begin tx is the keyword which is written. Okay, so operations like creating nodes, setting properties are performed within the transaction, and yeah, all these operations are performed within the transaction. So transactions are marked successful by making use of success, and finally the transaction is completed using the final function. Okay, so these are very important in order to understand how the transaction has completed, how the transaction is happening or not. Looking at an example here, we have transaction t is equal to database dot begin tx. So here we are starting a new transaction in the Neo4j database. So this transaction will ensure that all the operations within this are either fully applied or fully committed, or they are not applied at all. So either it is fully committed or it is rolled back in case of any error which is happening. Next we have try and finally. So try and finally block are made use in order to ensure that the transaction is happening properly, regardless of whether the operation has succeeded or if there is exception throwing up here. Next we have node n is equal to database dot create node. So here we are creating a node in the graph database. So the new node is a part of the current transaction here, and it will only be saved to the database if the transaction is completed successfully. Next we have is node.set property name NoSQL distilled. So here we are setting a property called name with the value NoSQL distilled on the newly created node. So here properties are like key value pairs which are stored in the graph. So thereby it will provide metadata for nodes and whatever the relationships are there. Next we have t dot success. T dot success will mark the transaction is successful. If it is successful, all the operations are committed and it is complete. Okay. Next we have finally. Under finally we have t dot finish. It will ensure that the transaction is properly closed regardless of whether it was successful or if any error has occurred. This finish will commit the transaction if it was marked as successful, or it will roll back to the initial in the other case. Okay. So if a transaction is marked successful, it will roll back. If a transaction is not marked successful, it will lead to failure, which will roll back. So making transactions as successful without finishing it will again does not commit the changes. That's what we have seen here, right? So in traditional data relational databases, transactions are implicit, but here in Neo4j, it requires explicit transaction control. So if we are speaking about the advantages, so advantages of transaction management, first one is data integrity. So throughout the process, data integrity is maintained. We are ensuring that data integrity is maintained even if in the cases of failure or interruption is happening. Next we have clean mechanism for handling success and failure. So transactions will provide a clean mechanism to handle whether it is success or it is failure, whether we have to roll back or commit further. Next we have prevention of partial and inconsistent updates. So again, by making use of graph database in transaction management, it will prevent of partial or inconsistent updates. Only if the update is complete, it will be committed. If not, it is rolled back to the initial stage. Next we have availability. So availability is again a very tiny topic, very simple one. So high availability with replicated slaves. So first topic is high availability with replicated slaves. So Neo4j achieves high availability by using the replicated nodes here. So replicated nodes means they are slave nodes here. So first committed write operations are performed first to the master, and then they are synchronized with the slaves. So other slaves will get the update eventually. So eventual consistency is being spoken here. So read operations are distributed across the different slaves in order to maintain the scalability. Apache Zookeeper, so it will manage the cluster configuration. Cluster configuration could be electing of the master node if the current master node fails, tracking the transaction ID, identification of master nodes. All these are the cluster configurations. So by making use of the Apache Zookeeper, it will help us to ensure that the system retains or it will remain available and it will and operational even if there is node failure happening. So thereby it is availability aspect is being covered here. So it has to be available even in case of network failure. That was about availability. Next we'll look into query features. Under query features we have this Gremlin. So Gremlin is a domain specific language for traversing the graph structures. So this Gremlin works with any graph database by implementing the blueprint property graph model. Next we have is the Cypher. So Cypher is the programming language or the query language which is used for graph traversal and querying purpose. Looking at the indexing. So in indexing, nodes and relationships can be indexed for quick lookups using the properties. So the indexed properties are used to locate the starting nodes for traversal purpose. Example for indexing, we have index node. Node index is the object which is created, that is equal to graph database graphdb.index dot for nodes, and inside we have written nodes. So here node index dot add Martin name Martin dot get property name. So here broadly explaining this, it will create or it creates or accesses an index that is called as nodes for storing index data which is related through the graph nodes. So this will add Martin to Martin node to this index by making use of name property here as a key for quick lookups. So this indexing mechanism is very useful or utilized when we have to efficiently query a graph for nodes with a specific property. So here properties have been specified, Martin, and with name. So here I'm specifying the properties, right? If I want to quickly find Martin node based on its name, I can do it very easily here. So I can perform the indexed lookup instead of scanning all the nodes which are present here, right? So this was about indexing. Next we have is traversal. So traversing relationships, that are relationships here could be the incoming, outgoing, or both. So traversing is a core concept to the graph database operations. So the direction filters could be incoming, outgoing, or both. Speaking about the order strategies, it could be breadth first or depth first. Let's look into the code here. The code for finding friends of Barbara. So traverser friends traverser is equal to barbara.traverse. Under that we have order should be breadth first, and stop evaluator at the end of graph. You're stopping the evaluation process. Returnable evaluator all but starting node. So here you are returning the end of so here you are determining which node are included in the result of traversal. All but start node will tell that all nodes will be included except the starting node. Next we have is ntype.friend. Ntype.friend will tell the type of edge or the type of relationship which you are specifying. Here it is friend only. The relation should be friend. Then we have direction.outgoing. It will specify the direction of the edge to traverse. Outgoing means it will go from one node to another node, or it will origin from the Barbara node. Okay, so here broadly speaking about this entire code, so here we are traversing we are starting the traversing from Barbara first node, then we are performing BFS breadth first traversal along with the outgoing edges of friend. Edge type is outgoing and it is friend here, right? So here we are including all nodes connected to Barbara, right, by outgoing friend, and we are accepting Barbara all but start node. So we are excluding Barbara but then including all other nodes here. So here by making use of this we'll get the traversal that is stored in the friends traverser object, and this code is useful for finding all nodes which are directly connected to Barbara through an outgoing friend relationship. This is a tiny example, but then if you are speaking about Twitter, so Twitter account of Barbara, you can easily get to know her friends who are connected to her through this code. Okay, so this is just a minute code. Next, we have shortest path finding or pathfinding. So pathfinding is another function. So pathfinding, the graph database can find path between the nodes and calculate the shortest path using the Dijistra's algorithm. So identification of paths between the nodes is taken place here. Okay, so here we have the code that is pathfinder path finder. So this pathfinder path so this path is an object that will find the path in the graph. So this entire thing will indicate the type of path that the finder will return. Next we have is graph algo factory. So graph algo factory dot shortest path. So this is a factory method that is provided by Neo4j to create an instance of shortest path algorithm. So the shortest path algorithm will find what is the minimum number of relationships with the minimum weight between two nodes, between the start and end, how many minimum nodes or how many minimum weight is present, right? So next we have all the parameters here. Friend, direction is outgoing, and maximum depth. So all these are parameters which have been specified. So by making use of this, finder object is configured firstly to find the shortest path between the two nodes, and it only considers paths between the outgoing friends. Friend is here and direction is outgoing, so only outgoing, and the search will stop after finding the specified max depth. So imagine a social media network where nodes are represented and people are present, and friend relationships are represented for showing the friendship. So this setup will find the shortest chain of friendship between two individuals up to a maximum number of hops which can be done. Next we have the Cypher query language syntax. So these are, here we have certain syntax of the Cypher query languages. First one is start. So start will define the starting node for a query. So it is used in to initiate a particular starting node. Then we have match. Match will specify the pattern to match in the graph. It could be the nodes or it could be the patterns. Next we have is where. Where will specify the filtering criteria for the matched patterns. So it can filter nodes, relationships, or properties using conditions like equality, comparison, logical operators, all those things, equal to, less, greater, all those things. Then we have return. Return will specify what data to return from the query, either it is node or relationship or any specific parameter has to be returned. Order by, we know, to sort the results based on specific order, it could be ascending or descending. Next we have skip. Skip is to skip a specific number of records in the record set, in the result set. Next we have is limit. Limit will limit the number of results that are returned by the query. Again, very simple. So next topic which we have is scaling. So graph databases are relationship oriented. We have seen what relationship oriented means, right? So making sharding is difficult when we are speaking about the graph databases, because the nodes are often needed to be stored on same server for performance enhancement. So when you are storing the database here, so all the nodes should be stored in the same database, right? So on the same server. If you are storing it in different server, it can lead to significant performance degradation. So what are the common scaling techniques which you can encounter? So this question was asked for 10 marks, guys, in the model question paper. What is scaling? Explain all the common scaling techniques. So the first one is incremented increased RAM. So we can store a working set of node and the relationship in the memory. So it is suitable only if the data set will fit within the realistic amount of RAM. So the RAM amount or the RAM storage is very specified, right? It is very limited. So if we are storing a large data set, then it may not be feasible here. Next we have is read scaling with master slave architecture. So we are making use of a master node for write operation and multiple slaves are used for the read operation. So this will help us with the availability and scaling, read scaling aspect. So this is practical for data sets that cannot be fit into a single node server, into a single machine memory, but they are small enough to replicate across multiple machines, that is dividing it into multiple servers here. Next we have is sharding using domain knowledge. So here we are performing application level sharding based on the domain specific criteria. So from the domain specific details which we have obtained, we are performing the sharding operation. Okay. So here, for example, if you see this node, the nodes related to North America are stored on one server, but then nodes related to Asia are stored on another server, right? So this, in this application only, the nodes related to North America are stored in one server, and here according to Asia it is stored in the another server. So you are doing the application level sharding here. From the application level, you are splitting the data into multiple parts, shards, and these shards are allotted different servers here. So this is a very simple example, right? So but then one thing here is, it requires understanding that nodes are physically separated databases. So by understanding or by ensuring that the nodes are on physically separated databases, we can implement the application level sharding here. Okay, let's look into the benefits of graph databases. So this could be clubbed with what is what is graph databases if it's asked for 10 marks. Okay, so first is scalability. So graph database can handle large data and it can scale out to clusters of machines. Next we have is performance. So graph database can query relationships very quickly because they are stored in the database. Flexibility is, they are very flexible, and they can store unstructured, semi-structured data. Real-time results means graph database can produce real-time results quick. That's why we are making use of them in the Twitter, all the social media networking applications, right? Social media recommendation engines, all these things. All these applications will require the real-time results. So here the querying should be very quick, very efficient. Next we have is relationships. So graph database can create and query relationships between the data. So when you are dealing with relationship oriented data or relationship oriented data set which is given, in such conditions we can go up with graph databases. Next we have is, what are the suitable use cases? First one is connected data. So under connected data, it is ideal for the social networks. Social networks would be Facebook, Twitter and all. So for example, if the suppose let's take employees and their collaboration on the projects, all these things could be connected together, or the relationships between different entities or across the different domains can also be connected in the connected data by making use of the graph databases. Next we have is routing, dispatch and location based services. So here nodes will represent the locations or the addresses, and relationships may include the properties like distances. So example here is G Maps, Google Maps. Okay, so it can be used, this application could be used for optimizing the delivery by minimizing the distances. We have seen Digistrust algorithm previously, right? Or recommend a nearest place of interest, that is restaurants or anything, right? All such things could be engines. Recommendation engines will optimize the recommendations depending on the personalized connections or the personalized node and relationship connections which are being established. It will do all this by identifying the patterns. So patterns are, for example, let's take Netflix. In Netflix, I'm watching, let's say, a horror series. In that case, if I've watched 10 horror series, it'll detect the pattern, and thereby it will help me or suggest me a new horror series accordingly, right? So those things can happen here. Next we have is fraud detection. Fraud detection can happen through the pattern analysis, which is again done through the same way. Next we have is supply chain optimization. Supply chain optimization can happen through the recommendations, because there are multiple nodes here, multiple relationships are there here. So we can optimize the connections between the supply chain, between the demand and the supply, and thereby understand the insights here, perform the analysis here. So in exam, if this could be asked for 5 marks, yes, and or it could be asked for 10 marks also. If it's asked for 10 marks, each and every point, each and every suitable use case has to be explained with 5 or 6 points. So check out the notes which are present in the Gdrive. So detailed explanation is provided there. Along with this, even this PDF would be available in the handwritten notes. When not to use, first one is mass updates. So it is not suitable for operations which will require updates to all or many entities. For example, analytics which will require the global property changes. In such conditions, we cannot make use of the graph database. Next we have is global graph operations. That is, some databases may struggle with handling large amount of data or performing global operations across the graph. In such conditions, we cannot use the graph databases. So that was about graph database. It is a very simple topic. Fifth module, fourth module are pretty easy. Do check out the model paper, the solved model paper, which is available in the Gdrive. If you have any doubts, do let me know in the comments, and stay tuned. Subscribe to my channel. Thank you.